Hello there, random smart person on the internet. You have probably seen these photos flooding your social media, YouTube, and even your cable subscriptions. You may have even wondered, what's the big deal? I've seen images like this from Hubble. What's new? By the end of this video, I hope you have a better understanding and perhaps a newfound appreciation for these photos. The James Webb Space Telescope is the world's largest, most powerful, most complex space science telescope ever built. Some of Webb's missions are to solve the mysteries of our solar system, look for distant worlds around other stars, and probe the mysterious structures and origins of our universe and our place in it. Webb is an international program led by NASA, with its partners, the European Space Agency and the Canadian Space Agency. The Webb telescope's camera captures images in the infrared part of the spectrum. This wavelength of light is invisible to our eyes. Our eyes can only see the visible spectrum of light between 400 and 700 nanometers. This is an extremely minute sliver of the electromagnetic spectrum. If NASA would produce exactly what it took a picture of, we would not be able to see anything. So the images themselves are computer enhanced, because they have to be in order for us to see them. Let's deep dive into some of these images from Webb. This is one of Webb's images that you may not have seen. This picture is of Jupiter. You can easily see Jupiter's red spot here in the image. Jupiter's red spot is currently more than 10,000 miles wide, more than 2,000 miles wider than Earth. It has been steadily shrinking for many decades now. This is the image of the red spot taken by Pioneer 11 in 1974. It looks substantially larger than those taken by Hubble and James Webb, but it's much smaller than in the 1800s when it was estimated to be about 25,000 miles wide. I will cover Jupiter and its red spot in more detail in a future video, but I just get excited when I talk about my favorite planet in the solar system. I know, hot take, I like Jupiter more than I like Saturn. While the most prominent feature in this image is the red spot, there are other fascinating details in this image. First is Jupiter's moon Europa, located right here. Europa is the sixth largest moon in our solar system. It is my favorite moon behind your own because it is theorized to hold more liquid water under its icy surface than all of the liquid water on Earth. It is one of the places that holds the most promise to find life inside of our solar system other than our planet. NASA's Europa Clipper mission will launch in October 2024 and will conduct a detailed reconnaissance of Jupiter's moon Europa. It will investigate whether the icy moon could have conditions suitable for life. Out of all of the missions conducted by NASA and every other space agency, this is the one I want to personally work on the most. Please, NASA, hire me. The next feature from the James Webb image that is notable is the shadow that Europa cast on Jupiter. This shadow right here is a solar eclipse taking place on another planet. One time while I was using my own personal telescope, I saw what I originally thought was Jupiter's red spot, but the dark spot was moving way too fast to be part of Jupiter's atmosphere. As it raced across the surface, I realized I was watching a solar eclipse on another planet, and I began jumping up and down in excitement. That was a really cool moment, and yes, I am that big of a nerd. Additionally, Webb was able to capture Jupiter's rings. This picture was taken with a 1-minute exposure time. Even though you can only see Saturn's rings from Earth with your own personal telescope, the 4 outer planets all have rings. Capturing Jupiter and its moons was an important test because astronomers wanted to capture images of comets and asteroids that move quickly in our solar system. Webb was designed with the requirement to track objects that move as fast as Mars, which has a maximum speed of 30 milliarc seconds per second when viewed from Earth's second Lagrange point. Let's move on to Webb's first image that was released, the Webb's first deep field image. I did a video on this previously. You can watch it after you're done with this video. I'll make sure to link it in the description below. But I want to go into more detail in this video. Let's zoom in and really take a look at this image. Besides the 8-pointed stars, you have probably noticed that some of the galaxies looked warped. For beings possibly living in these galaxies, their galaxy is not warped, but ours most likely looks warped from their perspective. This is due to gravitational lensing. There are objects so massive in between that galaxy and us that it is literally bending the fabric of space and contorting the light rays on their way to Earth. And when space-time gets warped that much, it can actually split light and make it seem that a single object is in multiple locations. That is what these galaxies are. They're the same galaxies, but the light has been bent and split so much that it appears in different locations. In this photo are galaxies that we have never seen before. And as you know, our universe is expanding. Space itself is expanding, and almost every object in the universe outside of our own galaxy's gravitational pull is moving away from us from our perspective. The universe is expanding at approximately 71 to 73 kilometers per second per megaparsec. The further an object is away from us, the faster it is moving away from us. Again, from our perspective. As the object is moving away from us, and as space is expanding, the light emitted from the object is lengthening. This is known as redshift because light is literally becoming more red. As light continues to redshift, it will shift past the visible spectrum and into the infrared and beyond. These objects' light actually disappear from our eyes, but it does not disappear from James Webb. Since the telescope is taking images in the infrared, it is able to capture these objects that have redshifted from our visible light spectrum. This is one of the many reasons why you can see objects in the James Webb image compared to Hubble. Now here's something you may not have seen, because it's really just data points, but it is just as impressive, if not more impressive, than what I've talked about already. This is a graph of the atmospheric composition of the hot gas giant exoplanet WASP 96b. This planet is located about 1,150 light years from Earth. It has a mass less than half of Jupiter, but about 1.2 times greater the diameter. It has a temperature of 1,000 degrees Fahrenheit and orbits its star every 3.4 days. 3.4 days. As Webb 96b passes in between its parent star and Earth, the light from its parent star dips slightly. This is how we know that there's a planet there. As light passes through elements, specific elements absorb specific portions of the light spectrum. Once NASA analyzed the absorption lines captured by Webb, astronomers were able to determine WASP 96b's atmosphere contained water vapor. This is huge. We are able to tell the atmospheric composition of a planet 6.7 quadrillion miles away. Yeah, I was able to sneak freedom units in here. Now, is it extremely unlikely that WASP 96b contains any form of life? It is a gas giant, and it orbits extremely close to its parent star. It is probably too hot and bathed in too much radiation for life to have gotten started. But that's not the point. We know the atmospheric composition of another world. This means we can look for Earth-like planets around other stars that could possibly support life as we know it. And finally, for this video, is Stefans Quintet. 4 of the 5 galaxies here are really close to each other. And if we zoom in, we can see that 2 of the galaxies are currently colliding with each other. This is what our galaxy, the Milky Way, and the Andromeda Galaxy will look like in about 5 billion years when they collide. The 4 galaxies in the center are 290 million light years away from us. That means the light that you're seeing from them left their stars 40 million years before dinosaurs walked the Earth. In fact, this light was emitted when trilobites roamed the Earth. I have a trilobite fossil right here. Trilobites lived from 521 million years ago to 252 million years ago. It is possible that the light in this image was emitted when this specific trilobite was alive. Stefans Quintet could unlock the way galaxies formed in the ancient universe. Tight groups like this may have been more common in the early universe when their superheated, infalling materials may have fueled very energetic black holes called quasars. Even today, the topmost galaxy in the group harbors an active galactic nucleus, a supermassive black hole 24 million times the mass of the sun. It is actively pulling in material and puts out light energy equivalent to about 40 billion suns. In addition to the colliding galaxy cluster, Webb revealed a vast sea of thousands of distant background galaxies reminiscent of Hubble's deep field. So there you have it. We have covered in detail some of the amazing images from James Webb. Comment down below on which was your favorite image and if you learned something new today. Comments are good for the YouTube algorithm. Whatever image was your favorite, always remember, have fun with STEM.